Hello and welcome back. So now let's move to this folder MRF, and here we have now our scripts and so on. So I'm going to focus just on mesh. I'm not going to add boundary layers. One, you can add it. We have seen that everything works, so it's up to you. To do things fast, I will keep with this script. So basically what we're doing is, as in the previous cases, we're going to run this propeller. We separated everything. Now in this case, we're going to use this geometry when reading, and that's all. Okay, so important thing, okay, boundary conditions, pretty much everything is the same. There is a difference here that later we're going to see when running the case, that is this new file there, that is the source stars that we're adding in a given region. And let me open it. So look at that and say, in this region, add this source star, okay, and in this case, look at that, we have rotational velocity, RPMs. Okay, this is the time or time step, and then it is scaling, no, it is increasing. So basically I want to add this in a region, but how do we create this region? Because so far we're creating single meshes, and that is what we're going to see. Okay, so pretty much the same, that is the only difference. And let's go here and let's open our file. So to be sure, we're running with this dictionary. Okay, snappyHexMesh body, let me open that, and there you go. So basically, remember, I'm not going to add the boundary layer, I commented, but also you have the extra step to add it. Okay, we go to the geometry. Look at that, it's very straightforward. Okay, the geometry, now we are reading the rotating. Now this rotating will be used, okay? And this is the one that is going to split the domain. And to make things clear, though, let me go here, and let me put everything. Okay, let me just Cessna MRF, and let me open here paraview 6 in this case, or 513. It's up to you. Okay, so go here, let me close. Okay, so go, let me open constant geometry. So we have the body. Okay, so look at this, is what we have. The body, we already studied. We don't have the propeller, then we're going to read a propeller. It can be any of the variations. Okay, so look at that, everything is separated. So the cylinder, the rotating, this one, basically is that one. And what we're going to do to say is that everything inside this region, now I can add a sourcer, or I can put it into motion. Okay, so look at that, you have this. So very important when creating this cylinder, you have to be super sure now that, and that's why now it's very important now to geometry, that you need to, okay, intersect the geometry in the right spot, otherwise you're going to get errors, so be careful about that. So besides that, nothing new. Okay, so let me close here. So we have our geometries, we keep reading the option. So as I mentioned here, pretty much is the same. Okay, don't change that, leave it as it is. Features, okay, so we already studied this, nothing new to add. The only thing that I can add here is that now that you have that cylinder, so you need to enforce in the cylinder, in the edges, just to have a good snapping. And sometimes that can be the tricky part, okay? So sometimes you will see that it's not perfect, the snapping between the cylinder and the outer domain. So as usual, most of the time the solution is finer meshes, okay? But remember that it's strongly recommended to add this snapping, otherwise you can have funky meshes. That can be a problem. Then surfaces, as we have done so far. So we're reading here, I can see that this dictionary corresponds to the fine dictionary. So let me go here and read instead the coarse, the parameters of the coarse. Doesn't change. Go here, rotating, we're reading everything, body. So body 6 is the propeller, and now this is the part, okay, the new part. The rest will be exactly the same. So let me jump here, look at that, you have your refinement boxes. Okay, you can apply one to the propeller, a surface on top of a refinement surface on top of the surface, I call it. So here is commentable is the one you want. You can comment it. This is a standard and no boundary layer. So easy peasy. The new step here is this one. So to create that cell region, there are, let's say, two methods. So you have this one that I commented. So usually this method, you use it when you want to create buffers. So you have here three options, and well, actually it can be internal, buffer, or boundary. Internal will mean internal cells, that what we want to do for MRF, okay? But for instance, it can be a case that you want to create a boundary or a buffer. So remember, this boundary or buffer is a zero thickness wall. So the difference here, if I will recall, okay, boundary will let you grow a boundary layer in that buffer. Buffer no, okay? So it is a zero thickness wall, but you cannot grow the boundary layer. So to remind you that also we have a tutorial, this A2 wedge, we actually will address that. Now we created a thin cut and then in the leading edge and interpolate there. So we'll address that. But you have this option. The one I like to use for MRF and NCC, it is the simplest one, not to avoid confusion. It is this one. So this one you just can limit if you are interested in creating buffers. Okay, buffers or boundaries, okay, you use this one. Otherwise, go for this one, the easiest one. So rotating, okay, mode inside this region. So remember that this is the entity that you are reading here. So you use that name. Okay, mode inside, and then cellZone and faceZones. Okay, so you create a cellZone, you give it a name, and you give it a name to the faceZone. And now this can be used to do our topological splitting and so on. So for the MRF, it is enough to have this region. Okay, if we stop before doing the NCC. If we want to do the NCC, we're going to use this information. We're going to see that later. So pretty much that's it. So my advice now here when creating these regions, you do use this method. This is the easiest one. By the way, there is no limitation. You can have many regions. So if you have 3, 4, 5 propellers, so read your geometries and create your regions. Obviously, give it a different name, but that's it. Okay. At this point, nothing else to do. Okay, pretty much the rest is the same. So let's create this mesh. Okay, and let's see our results. So remember that I'm going to do the mesh. I'm not going to do the boundary layer. That I leave it to you. We know that's where it works. Let me go here, and to be sure that I want to create the quartz mesh, I'm reading this propeller, and that's it. So I forgot to load OpenFOAM. So let me go from clean tutorials to do some cleaning, even if it is already here, but anyways, and off you go. So let's wait for the final mesh. Okay, so we're back. We have a mesh. I want to remind you that I'm running with 28 cores, so adjust this one according to your number of cores. Also, well, we have all the log files. I also want to invite you just to read the output of the screen of the machine, and you have everything there. So remember that, and let me go back here and to stress that hopefully for the last time. The first step, castellation, is where you are going to add to do all the cell addition. Snap is where you make the body fitted mesh, and then here you add the boundary layer. So let me go here and let me open check mesh. So as you see, pretty much a perfect mesh. So a little bit no orthogonality, a little bit high according to the criterion defined, but this doesn't mean anything. It's up to you, but this is a good mesh. And then here you have your output file, log file of blockMesh. So just to read a little bit what we have here. So remember to check everything what is happening. Be sure that you are reading all the image. So I like to do, even if you're forcing that here and telling, okay, read this image, this file, just take a look, because sometimes personal experience happens that, I know, for whatever reason doesn't read that file. So just take a look and be sure that you are reading all your files. So all that information, usually you have it at the beginning. Okay, you have your geometries, the patches, everything. This is, look at that now, is you check the previous case, this didn't exist because we were not creating that. So this name it is created automatically. Okay, then it will be renamed. Okay, and that's it. So look at that. You start to do all the process, the cell splitting and so on, the castellation, and it starts to measure the quality. And as you look at here, pretty much 0 cells that are violating your mesh quality requirements. Okay, so usually that is the case for the Cartesian meshes. They're all Cartesian, so everything should be perfect. Uniform cells. So probably you're going to see some issues if you have no stretching in the background mesh, or you did something really wrong. But let's say other from that, this should be always 0, 0, 0 now. So no cells violating your criterion. So as you see some cells there, be careful. Can be indication that maybe you can improve something here. So you have this one face with face twist. So probably I think I would prepare a video just to show better what is this. But usually this is close to the surface where you have the body, but pretty much everything is great. Okay, and now you pass. Actually, you have that, and I think I already was in the. Okay, yeah, we were already here in the morphing stage. Now we were doing the snapping. So let me go here. Okay, so final balancing. This is for the previous step, and now I start to do the snapping, and here's where you start to see that bad quality. That is not that bad. Okay, and what it's doing now, every single iteration that you see here is just trying to enforce the mesh quality criterions that you are defining in the mesh quality dictionary. So an advice, be careful this dictionary. Don't put values too low, because it can take a lot of time, and it's not guaranteed that always will fulfill. It will respect these values. Okay, it will try to do its best, but there is no guarantee. And then you have this one that mainly related close to the boundary snapping, and also the boundary layer meshing. They do have a strong influence there. So, and this is it. Okay, we have at this point we have perfect mesh. Okay, here, okay, so doing all the iterations. So these steps that you have here, let me go here. This represents the end solve, iter, and so on. These are the iterations, but you see here is redoing and redoing, iterating more and more, just to try to enforce your quality metrics, or until it reaches the final iteration. Okay, so as you see this, you might think it is a difficult mesh, but look at that. Didn't take too many iterations. Now, knowing what we do, remember always the finer the background mesh, and also the finer the surface mesh, the better the result will be. So here it is. We have a good mesh. So now that we have this, okay, let's visualize after this discussion. Let's visualize our mesh, because here, and actually let me open another tab, we have that cell region. Okay, so let me go and see the constant, see the polymesh, and look at that. Here you're going to find faceZones and cellZone. So when you see this one, it means that you created that cellZone, you have it there. So more cellZones, and there you go, rotating cell, and this cellZone you can now access that. Okay, so let me go. When you open paraview, I'm not using the built-in option now. So you have here zones and sets, and you can access that information. So let me go here and see that exactly the name that I gave in the snappyHexMesh file. You're going to have it here, and this is it. So now you have two domains. Okay, you have this one, and then you have the external domain. So let me go here, and let me add here normal to y, normal to y here. Okay, so bam 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 bam. Let me go here. And look at that, this region is exactly corresponds to the cylinder. Okay, and then the cellZone that I created, you have it there, and you can apply there whatever you want. I want to stress something. Look at that, what we have here, and this can give some problems. And let me add another cut plane there. So let me put it 0, show cut plane. And so far everything looks perfect, but this is an issue that, and this is why the NCC can be better. So as you look at clearly, and let me just to demonstrate it, and constant geometry rotating. So this is the cylinder, the surface that we're using now to create that region. You have it there, okay? So if I zoom in there, look at that. It is not perfectly matching. So remember the issue with the boundary layer, some collapsing, and this is tricky to control. No, that's why I say that sometimes it's good to increase the feature in the edges, also to add the edges to resolve the edges in this region better, is to avoid these issues. It's difficult to control, honestly, in snappyHexMesh. I don't know the reason, because it should be perfectly matching, but for some reason you don't get it. Yes, you use finer meshes, and yes, you take that surface, for instance, you go back here, and in this rotating refinement region, actually you go to refinement surfaces, and not surfaces, this will be surface on top of a surface, and you can add another like this one, a distant mode, okay, on the cylinder, finer cylinder. It can improve, but still sometimes you are going to have these issues here, okay? So this mismatching can give you problems in the interpolations you are using in sliding grids, but also with the MRF approach, it can add some sources of errors that we're going to see, okay? So this problem usually is solved with the NCC. You improve that. So that's why I say it's better to use NCC, but finer meshes can help a lot. The other option, recall that in the boundary layer in the previous tutorial, now of this one, the Cessna, we talk about that it's very important to have cells normal to the surface to avoid that stair-step behavior. Well, something similar apply here. So if you recall again, and let me go back here, and we have this tutorial A2 wedge, where we added a boundary layer in a baffle that will be equivalent to this one, zero thickness surface. Okay, so you can add, it will be enough to add one layer to enforce to have everything normal to that surface that you used to cut the domain to create this cellZone. I have to stress something that is already, this one is going to give you a good result. So by adding that, it will be an improvement, but it's not compulsory. It can be tricky to add. I have done it. I'm not showing here, but you have all the steps, previous tutorials, and you will see that you can do it easily. But honestly, depends, okay? Because it can be tricky to control, in special this case, that if I rotate here, you will see that now you are going to have here this intersection. So you are going to create a boundary layer here, and it can be a little bit tricky to control here, to have this, the right boundary layer growing. But that's it, okay? So that is an optional step. It's not good, it's not bad, okay? It's up to you to try it. Honestly, I just use it when I get very, 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 very bad meshes here, this region. But in this case, it's not big of a deal. I know it's okay. And later when we run NCC, we're going to understand how to measure those values. But that's it, okay? We have that region, we access everything, and now this can be used now to run the simulation. So let's go the next step, that is creating the NCC from this mesh. For that, let's go to the next video.